Hello, welcome all. Myself Kiran. I am from Department of IS SVC. Today we will learn about core concepts in DBMS. First, let us see the outline. Data modeling, entity relationship diagram, that is ER diagram, symbols used in ER diagram, data connectivity, and the concurrency control. And last part is the conclusion. Okay, first let us see the definition of data modeling. Data modeling is nothing but organizing the real world things and connections in the organized way for the database. Okay, data modeling is nothing but organizing the data in the database so that we can easily access, we can easily perform the operations, we can easily manipulate the data. That's what the meaning of the data modeling. Okay, next let us see the ER diagram, that is entity relationship diagram. It's a flow chart that illustrates how entities such as people, objects, concepts relate to each other within a system. Okay, before going to definition, I will tell the meaning of entity. Entities are nothing but people or object. Okay, don't get confused. And entity relationship diagram depicts how the data in the database are related to each other, or how the relationship exists between the data. Okay, and let us see the symbols used in ER model. First one is a rectangle, it represents the entity. Okay, and next one is ellipse, that is you can see the symbol and it represents the attribute. Okay, next one is a diamond, and you can see the symbol, I had given the symbol, and it tells the relationship between the entities. Okay, and I will give you a simple example. Bank account is also an entity and person is also an entity. The person can have account in the bank, so these two entities are related. How we can show that in a ER diagram? By using the diamond. Okay, and ellipse, if you consider ellipse, it is an attribute. Okay, person is also one entity. Person can have email ID, phone number. Okay, these email ID, phone number are attributes, and we can mention these two things using ellipse in the ER diagram. Okay, and the next one is a line. You can see the symbol and what it represents. It represents attributes to entities. Okay, and double ellipse, you can see the symbol and it represents multivariate attributes. And the next one is double rectangle, you can see the symbol and that represents a weak entity. Okay, let us see the one example of ER diagram. You can see the employee and account. Employee and account are both entities. Okay, and employee is having one account in the bank. Okay, so employee deposits some money in the bank account. Okay, these two are connected with the help of diamond. Okay, and employee can have employee ID, employee name, employee street, employee city. These are nothing but attributes. Okay, and it represented using ellipse. And account have two attributes, account number and total balance. Okay, and let us see database normalization. Organizing the data efficiently, minimizing redundancy by breaking down information to smaller and manageable parts. I will tell you it in simple words. Data normalization means nothing but minimizing the duplicate values so that we can access the data very conveniently, and it avoids the usage of extra memory. Okay, and importance of reducing redundancy, avoids repeating data, ensures each piece of information is stored only at one place. Okay, so we will be having the unique data in the database. Okay, improving the data integrity. Data integrity is nothing but maintaining the accuracy and ensuring data consistency, maintaining the uniformity. Okay, and query optimization. Query means we tell the database so that it can provide the data back to us. It is possible with the help of query. Okay, and for faster retrieval and faster access of the data, we need query optimization. Okay, efficiency boost, making database searches faster and more effective. Okay, indexing, creating shortcuts for quicker data retrieval. These are some of the techniques for query optimization. Okay, don't get confused. And proper query design, structuring questions for optimal database performance tuning, fine tuning to improve overall query responsiveness. And let us see transaction, a task that must be finished entirely in one go, the task that should be completed in one go. Okay, it should not be completed in half of or 3 by 4 and 1 by half, not 3 by 4 or 0.2425 like that, okay. And in that atomicity, ensuring task completed fully or not at all, okay. It should not start, or it should if it start, it has to complete to the full, okay. Consistency, keeping the data accurate and reliable during and after the task, that is maintaining the accuracy or integrity of the data. And isolation and durability, shielding tasks from interference and preserving results permanently. And data connectivity, allowing programs to communicate and exchange information with the database, application interactions, making software able to access and use the database resources seamlessly. Database connectivity is nothing but applications or the programs that can access the database. That's what the meaning of the database connectivity. And API is nothing but application programming interface. API, if we send a request to the database, we cannot send the request to database directly, so we need an intermediate to send the request to the database from the front end. So we send the request to the database via API from the front end, and API will fetch the data from the database and it will give it back to the front end, okay. And middleware, software connecting different applications and database, promoting smooth communication, efficient data exchange, ensuring swift and reliable sharing of information between the application and database. And concurrency control is nothing but allowing multiple access to the database, okay, from the multiple users. And simultaneous access management, overseeing multiple users to ensure database actions occur smoothly. So if many users try to access the database simultaneously, there should be a mechanism to support this, okay. And that's done by concurrency control, okay. Locking, temporarily preventing access to a specific part of the database to avoid the conflicts. In concurrency control, we use locking method, so that suppose if one person is accessing the data, which is very sensitive, and after that person only accessing or finished the work, then after that only other person can access. That's what the meaning of locking. Time stamping, assigning unique timestamps to transactions to order and manage concurrency operation effectively. That is, we assign timestamps to the user, so that in that specific time only you can access the database. And it is the data backup and recovery, and it is a main advantage of DBMS also. If we use MS Excel, we can't recover the data, okay. And if we delete the data, we can't recover the data. But in the DBMS, we can do recovery as well as the backup. Importance of regular backup: safeguards the data against loss, creates copies for restoring important in case of emergencies, okay. We can do regular backups in the DBMS. And backup strategies: plan for creating, storing and managing backups, including frequency and storage location. Data recovery methods, as I told, there is a data recovery mechanism in the DBMS, so that once, suppose if we lost the data by mistake, we can recover the data. And the last part is a conclusion. Essential foundation, these concepts from the bedrock or effective database management. That is, we should have strong foundations in order to enter to the database field. And optimizing operations, once we store the data in the DBMS, it's very essential to optimize operations, because if we store large amount of data, it may become slow. We should not let that to happen, okay. So we should find a way to optimize operations, optimize the query operations, and so that data integrity and data reliability is maintained, okay. Reliance strategies, backup recovery plans ensure data safety amid unforeseen challenges, okay. Main advantage is we can recover the data, we can back up the data, but these facilities are not found in MS Excel. So most of the people use a DBMS, and MS Excel can't store huge amount of data, okay. Suppose if it stores also, it works very slow, okay. But DBMS not works in that way. If you store huge amount of data, its performance or its speed does not decrease. You can access the data very fastly, even when we have large amount of data in the DBMS, okay. So this is the conclusion. Thank you. If you have any doubts, feel free to write the comments in the comment box. I will be there to assist you. Thank you. Have a nice day.